Is life just chemistry and physics? This question wonders if things are just the sum of their parts. Complexity theory, the topic of my research, says no, so let's talk about that. I'm going to contrast two theoretical perspectives, those of reductionism and complexity. In reductionism, systems can be understood from their component parts. Causation predicts outcome, and they're really good at describing linear systems like pulleys, gears, and cars. Complexity, on the other hand, thinks that some systems cannot be understood by their component parts in principle. Those systems are emergent gestalts, arising unpredictably greater than the sum of their parts. And it's best at describing dynamic, adaptive, self-organizing systems, those of learning systems. So why is this important? Well, reductionism has been the dominant term in Western science and is rooted in Greek thought, whereas complexity is relatively new, especially to education theory, and aligns better with neuroscience. My research, titled Making Complexity Real, identifies a problem in complexity literature, that it's often very good at describing the very small, like cells or the immune system, or the very large, like classrooms and economies. The purpose of my research is to try and make complexity theory understandable on the scale of a single student. My research is designed as a piece of hermeneutics secondary analysis. The Mathematical Science Research Institute, Volume 53, contains a formative assessment interview between teacher-researcher Ball as she attempts to uncover Brandon, a 5th grade student's understanding of fractions. My job is to take literature on complexity theory and then reinterpret through secondary analysis Brandon's responses. Alan Schofield, a professor and editor for MSRI, has his own classical analysis, and I contrast this to help further describe complexity. Some of the key interpretations about Brandon's responses. Brandon's relationship to his education is chaotic. The intentions of curriculum are apparent, but his errors are wild, creative, and a synthesis of previous experience. Brandon's mistakes are examples of internal coherence without external coherence. It makes sense to Brandon, but not to math more generally. Brandon's understanding exhibits the behaviors of a network. He doesn't have a singular idea, and these interact in a decentralized way that he's not entirely in control of. All in all, Brandon's understanding is an emergent gestalt formed by a complex web of associations rooted in embodied experience extended through blended metaphor. So how does this interpretation compare with Schofield's? Well, we agree that pen and paper testing can't uncover understanding. We also agree that learning is not a linear process. But we disagree that Brandon is missing pieces of the puzzle. Like a key that doesn't fit a lock, Brandon is coherent as a key, just not externally coherent to the lock, and the addition of yet more teeth is not going to solve this problem. We partly agree that more experience is required, but that it's going to reshape Brandon's understanding rather than adding to it. So what recommendations does complexity have for teachers? Well, first, embrace chaos. There's no one-size-fits-all lesson. Multiple different understandings are going to exist no matter what you do, and that inherent randomness is the mechanism that fundamentally enables adaptation, plasticity, and learning. Foster and facilitate discussion to use this. You are teaching to nested networks. Ideas are the gestalt of synapse, students are the gestalt of ideas, classrooms are the gestalt of students, and mathematics is the gestalt of 30,000 years of human social endeavor. All of these scales are going to interact, and so you're teaching in the middle of them. As a teacher, you're in the middle of a vast network of interactions ranging from instants to millennia, from individuals to classrooms, and you're trying to encourage or suppress what's emerging from this. To Schofield's point, this is nonlinear and it might not go as planned. So if you take nothing else away, take Ball's point. That it is through careful, patient interaction, testing without judging, that you uncover a hidden world. Thank you so much for watching. My name's Forrest Payton. I've included references and footnotes on the following slides and links in the comments below.